Enjoy with me the next presentation dealing with the topic fuel cells in BOS digital radio communication. And your presenter is Mark-Uwe Oßwald from the company FutureE Fuel Cell Solutions GmbH. Give him a big hand.
Thank you, Kirsten. Hello, also a warm welcome from my side in this afternoon. Thank you for being so many people here and being interested in my presentation about fuel cells for professional mobile radio. In Germany it's called BOS, Behörden für öffentliche Sicherheit. This is a special radio equipment. And we have here in Germany the big opportunity and the big chance that we are taking a leadership role in providing backup power via fuel cell systems to this special application. Leading through my presentation, I very much focus on pictures because I believe pictures tell much more than words. As a short entry, here an example of our fuel cell system. It comprises 19-inch fuel cell modules converting hydrogen and the oxygen from air into power. FutureE was a startup company in 2006. We have meanwhile delivered into more than 10 countries our fuel cell systems for backup power applications, mainly in telecom, but also in utilities, industry, and lately also railway applications. You see a typical fuel cell system, you see it also from other players in the field, consists of fuel cell modules, each providing a certain amount of power, in our case 2 kilowatt, and you can combine them so that you can achieve at higher power levels. In our case, here this example shows an indoor solution, but we also provide these or deliver these fuel cell systems in outdoor configurations or in containerized solutions. Coming to it later. And now I go directly into the topic. I assume everybody here understands what a fuel cell is, so I left out all the introductory. I also left out the introduction of FutureE. Please visit our website if you are interested, or come to me. I give you a business card afterwards, www.future-e.com. But also please feel free to ask me if you're more interested in our company. So this is actually a fuel cell system which we have deployed in Germany for professional mobile radio in the BOSnet. You see here on the right-hand side the fuel cell modules. So altogether here 6 kilowatts of power. Down there the power electronics, because the customer wanted 380 volts AC. A fuel cell is a DC generator. It's an electrochemical device providing DC power. So there's power and electronics involved here. At the very bottom, a small set of batteries, because a fuel cell needs a starter energy to get started. And on the left-hand side, you see here one door open which houses 6 hydrogen bottles. The customer here was very particular that all this system, the fuel cell as well as the hydrogen, is comprised in one integrated enclosure because it shall be vandalism proof. You know, this is power supply for radio equipment, so it is very crucial that in all case of emergencies or vandalisms that this power supply remains intact. So you might know it from your personal homes or your apartments. There are certain resistance classes for equipment for burglary or vandalism, and this housing here is vandalism class 4. So it means an experienced burglar or vandalist, it takes him more than 30 minutes to get into this equipment. It's hammers and whatever tools they use. So I'm talking about this housing here. So you see I'm talking a niche market or a special market. It's not everyday's fuel cell application. It's a certain application, you know, high security equipment, which is protected here also with a relevant housing. Very important when it comes to fuel cells for professional mobile radio is also the efficiency of such a fuel cell. because the decision point for a fuel cell is mostly related to the fact that you want a long autonomy time in case of catastrophe. You want to be able to communicate, to exchange data for a lengthy time. And there's two ways to achieve extended autonomy times. One way is to put more hydrogen on site, and the other way is to use the hydrogen which you have on site more carefully, more efficient. So high efficiency of a fuel cell system is a decision point, especially for this niche application or for this special application, professional mobile radio. So that was the introduction into fuel cells for backup power. And now I'll come via this slide into the BOSS cases. In general, when you decide for a fuel cell system for backup power, you have alternative options. You can either choose an established solution, which is a battery solution, or you can choose a diesel generator solution, you can choose a combination, or you can choose a fuel cell system. And in here on this slide, in general, you see the decision process which goes along a TCO cost analysis with these three options: diesel generator, battery, or fuel cell. And the orange one, that is the fuel cell option. So you have, in this case, for 12 hours backup time, a higher investment cost, like a battery solution. However, with the operating expense, you meet a TCO break even after 3 to 5 years. This is just exemplary. An example, this really depends from customer to customer, site to site. But in general, this is a decision process which all the backup power, whoever makes a decision for backup power goes through. And this was also a type of decision process State of Brandenburg went through, which I come to now. So the whole question is, why fuel cells for professional mobile radio? And when I started the company with my two colleague founders, my two founders, one is back there, Sigi Limmer, I never thought about, I did not even know about professional mobile radio. It's such a small application, and I never thought about that this might be our target market at 7 years later. However, it turns out that fuel cells are a perfect fit for this application because hydrogen has such a high power density in terms of energy storage that it is a even commercially much more beneficial application than, for example, a large bank of batteries or a diesel generator, which requires a high amount of maintenance to achieve the same uptime availability. So this is a perfect fit. And I go now into the examples here from BOSS Brandenburg. For those of you who are not from Germany or not involved in detail, BOSS Brandenburg, the Brandenburg state in Germany, is a leading state for professional mobile radio equipped with hydrogen fuel cells. They have tendered fuel cell systems, 116 fuel cell systems in early last year, and in 3 lots. And I was permitted to show these slides, which were used by the state of Brandenburg for the decision process. So the following slides are from the state of Brandenburg, from Mr. Baltruschat, a police officer, who is also the work group leader for the Wasserstoffnetzersatzanlagen, hydrogen generator replacement equipment. And please forgive me, it is, these are original slides, they are now in German, but I hope you will get the message. Die Aufgabe, the task, to equip 116 locations with backup power for professional mobile radio. And keep in mind, the whole region of Germany, there will be about 4,300 such mobile radio base stations to be equipped with a digital radio equipment. In Germany, it's TETRA, terrestrial trunked radio. It's a special, what shall I say, like GSM or LTE. It's a special equipment which the police and the security forces use for the communication. And the state, each individual state, we have in Germany 16 states, has a decision authority what to do for backup power. And the state of Brandenburg is leading the pack, I can say, in terms of deciding in favor of fuel cell systems. Again, alternative would be a diesel generator solution, a large battery bank, or mobile generators. However, they decided to equip the majority of their base stations with fuel cell systems for the following reasons. Key decision maker for the state of Brandenburg were major catastrophe events in Germany. Although we enjoy a very high power uptime here in Germany, we also had sometimes catastrophes like Kyrill, and you see here the effect. 47 people died, and we had up to 24 hours of outage times, power outages. And in some regions even 48 hours of power outages. A very unusual event in Germany. And if you as a minister in charge want to do something for the safety of your people, this is what drives you crazy, if something like that could happen. So you think about alternatives, and one alternative is of course a fuel cell system. Something similar happened in Münsterland, which is here in Lower Saxony. There was a snow chaos in 2005, and according to RWE, a power utility provider here, even in some regions, even 4 days after, there was no power. There were animals slaughtered because there was no power supply for the farmers, and because it's an animal-rich region, I mean, in this area. So these events that really triggered was a decision-making for Brandenburg to go after fuel cell systems. So here it says, when the mobile radio, the standard mobile radio fails, or the main telecom lines fail, boss people, the police, they still have to be able to communicate. The fire brigades, the technical Hilfswerk, they all have to be able to communicate and then to put the country back into operation. So this is a very utmost driver for the decision making of the Ministry of Inner Affairs. They compared it via diesel generator. I don't want to go into details here, but just you can find it on the internet later on. But there were pros and cons. The biggest cons for a fuel cell simply is the fact that we don't exist that long as a diesel generator. It's kind of unknown. It's not that established like a diesel generator solution. But fortunately enough, we found in Brandenburg an organization which went for it, which took that which not ignored it, but which was rather more going in the future than rather looking in the past. They also did a financial analysis, and this is in numbers, the graph from very early. This is market data which I collected in 2011 from various suppliers. Showed them, well, the startup costs are in the same range like a diesel generator, but the operating expense are lower. So this is consistent with the slide you have seen before. And then decided what are the key requirements for such a solution. That's here. And you see, they wanted to have 72 hours of autonomy time. That means a long weekend of operation so they can recover operations and bring everything back to work from a Friday noon to a Monday noon, essentially. And well, this is one of the solutions. We are proud that from the tendering process we won with our partner in the first lot. We are also providing our fuel cell systems in the third lot. And this is an example, as you have seen it earlier. It's a vandalism 4, class 4 enclosure with fuel cell it's exactly the same, with fuel cell modules and 12 bottles providing at 2 kilowatts even around 100 hours of autonomy time. And I guess I'm still in time, so I can still show you some reference cases. Going beyond professional mobile radio, we also offer fuel cell systems in enclosures like containers, or in this case it was a concrete kind of garage for an inner, city. You know, in the inner city there is the representatives, the house of the mayor, and they wanted to have backup autonomy time also for 72 hours for their computer system. So it looks like a garage, integrates well. This was a backup power solution for Telekom, Deutsche Telekom, providing backup power for their network nodes. And here it becomes very nice. You can also nicely integrate fuel cell systems with renewables, in this case with solar and wind. This is a power station by E+, and you will hear later from E+, and you'll hear more about it. It's a great way to do a 100% zero emission solution. And now I want to thank you very much for listening, and I'm very open for you to come and ask more questions, and hopefully you also bring some more orders into our house. Thank you very much.
Thank you very much for this quick, short, interesting, informative presentation. Yeah, I like to continue directly. And thank you, Mr. Oßwald. You are staying here at the technical forum, right? A little bit at the bottom. So if there are any questions or you like to discuss any topic with Mr. Oßwald, please go straight ahead to him. And he will stay here for a long time, I think, today. So, like I mentioned, we will continue directly now with our next presentation, dealing with the topic 24 kilowatt fuel cells, the best solution to achieve more than 1 MV. And your presenter is from Proton Motor Fuel Cell GmbH, Mr. Hermann Seim.
Yeah, hello, my name is Hermann Seim. I'm from Proton Motor Fuel Cell GmbH, and at first I want to say thank you to Mr. Axthammer and CPN to give me this opportunity to introduce myself and the 20 kilowatt fuel cell system project. And in fact, I have to say thank you twice, because this project would not be happen like we have done it without NOW, also with Dr. Axthammer, Mr. Axthammer. Thank you. Okay. Well, I want to start into this presentation with a quotation. And it's a quotation of a German mathematician. It's Georg Christoph Lichtenberg. He lived in the middle of the 18th century. And he said that the human tendency to regard little things as important has produced a lot of great things. And as you may see, the photovoltaic industry shows this like every day to us. And what I hope, or what I'm here for, is that we do this with fuel cells too. So fuel cells. I will talk a little bit about development considerations of this project, this 25 kilowatt system project. What does it mean to production, operation, services? And on the second part of the presentation, I will talk about the costs of this system, and especially what means it to scaling of the systems. Okay. We had, of course, some main requirements of the system, just beside power requirements, of course, and main requirements was for sure that we have real industry standards. And so we decided us in the main housing for a 19-inch rack as a industry standard. We wanted to have a really reliable and durable fuel cell technology, well-known technology, so we have a really low risk in development, and with standard interfaces, of course, we make it easy to handle the system. And with all these requirements, we come to our development achievements. Just, of course, a fuel cell stack. It's an high power stack, liquid cooled stack with electrical power output of 30 kilowatt, peak power output, with a high efficiency greater than 50 kilowatts. And we generated already a lifetime greater than 10,000 hours, and we are very confident to make it into the future more than 20,000 running hours. Well, a fuel cell stack by its own means not much, because what we need is a good system all around this fuel cell stack. This makes it very great. And this is what you see down there is our S25 module. We decided us for the main part was to reduce complexity of the system to absolute minimum. So we decided us to modular system architecture. We have a fuel cell module on the one hand side, and on the other hand side there's air module. In the fuel cell module is of course fuel cell and all the hydrogen components with cooling cycle is inside, and on the air module all what we need like air compressor, like the air filter of course, and the intercooler. What we needed to do, or we decided to do, is we have a two circuit cooling cycle. So we have a very small internal cooling cycle into this fuel cell module. So it makes for everybody and every system integrator very easy to integrate his system in may existing cooling system. Or in fact, you can use every kind of cooling system you want. Even with you can cool the system even with oil if you want. And so all in all, we are sure we developed a very easy installation for this systems. Okay, this is our achievements of at the development, and we are already at 20 kilowatts or 25 kilowatts. So what does it mean? Why? How to come to the 1 megawatt? Of course, right now we can put two of the systems consisting out of 4 modules into one 19-inch rack. So we have already 50 kilowatts, and if we take 20 of them, it's 1 megawatt. Sounds very simple, and in fact it is, because the footprint of these 20 racks are just 19.2 square meters, and if we look to another real industry standard, like a 40 feet container, for example, with an internal ground space, ground area or the floor area of 28.2 square meters. We already checked this. We will get this 1 megawatt into one of this container. Yeah, so I come to the issues like production, operation, and services, of course, and I'm gonna start with production. As I said before, we have 2 modules. So this relatively small modules makes it easy to handle. We don't need any crane to produce them. We don't need any special toolings, and we can produce these systems on very small production lines. So what does it mean? In fact, if we need to rise our production because of a big order income, we just add in parallel some more of these production lines. So what we can do right now is raise our capacity of production in small steps. And I think it's a big advantage of the system. And operation, well, if you compare this fuel cell and the scalable fuel cell systems with standard or actual conventional power plants, if you need only half of the output power for a certain time, then we double, in fact, for this certain time the lifetime, because only the half of the racks will run at nominal power. That's I think quite easy to understand. And what we also generate with this way is a very high availability, because even in fact, every module by itself, or every system is an own system. It can run by its own, and we have a very high redundancy, so it gives us a very high availability for the system. And last but not least, the service maintenance is possible while operation, not of the system itself, but if you see it as a whole power plant, you maintenance, or we can maintain one rack, even if all the other racks are still running. So if we have 1 megawatt, 20 racks, one rack is off, 19 racks are still running. And so it is a maintenance while operation, again high availability. And it's no real high qualification needed, because if, and I hope it will never happen, but you never know, if one system fails, you just take the module out, and the module is sent back to our company. It will be repaired at the company, and sent back to the power plant and get in. And so it's no really knowledge of how to operate or how to repair fuel cells needed. So all this together sounds really great, and of course everybody, or I think most of the people are interested, where is the bottleneck, what does it mean to cost, for example. So it's the other half of the presentation. This is a cost analysis of this actual S25 system, and if we have some fuel cell production company here, they already know we have more than 2/3 of the system in our system, which are stack costs. And so I will look for this cost at first, and afterwards I'm gonna look to the balance of plant again. This is the cost of the fuel cell stack, of the whole stack, of the 30 kilowatt stack. And as you can see, it's 3 components, which makes 97% of the fuel cell costs of the whole stack. It's bipolar plates, catalytic coated membrane, and gas diffusion layer. And I will look now a little bit more in detail on for these 3 components. What does it mean in scaling, the scaling effects of these 3 components? Well, on the left-hand side, it's absolute value. Of course, I can't show you this real absolute value, but it's in the same scaling. And what does it mean in number of ordered parts? And on the right-hand side, this diagram shows it in percentage. And as you can see, even if we just build 40 systems, 40 stacks, we already get a cost reduction of more than 40%. And I think that's really a lot, even if it's not so much systems. Well, I look to the balance of plant too, and even surprisingly for me, again on the left-hand side we have the absolute values, and on the right-hand side it's in percentage. And again, we got not 40%, but 38% of cost reduction, even in this small amount, which means 1 megawatt, in fact. Yeah, now I'm close to the end of my presentation, and I want to just look what does it mean overall. And at first I want to say actual conventional power plants. There exist lots of studies of investment costs of this power plant, and nearly all say that from the past to now, the costs of a conventional power plant were rising, and in fact, they will rise into the future. And that the prices of coal, gas, and oil will rise too, I think everybody knows. It's nothing new for everybody. Fuel cells have a real high potential to reduce costs. And the left-hand side are the cost reduction of just 1 megawatt. Now, it's just the left-hand side is just an extrapolation. Because nobody won't give you the exact values for 3,000 units right now. But I'm very convinced we can achieve this. And even at 1 megawatt systems, we already right now achieve with this Proton motor S25 fuel cell systems the costs of, or the investment costs of conventional systems. It's even right now it's below 1,500 euros per kilowatt. And if we come to the point of, for example, a small gas turbine, steam turbine power plant, we will be much more. We will reduce the costs, of course, even much more. And if you are at this point, I can tell you the cost will be even below of a gas turbine and steam turbine. This combined gas turbine to steam turbine power plants. This is what I know. I calculated a lot of this, and when I start this project, I was a little bit skeptical if this can be, and I by myself, I'm convinced, and well, I come to my conclusion. It's very fast and very short. In fact, what I can tell you is the technology is ready. It's prices of today, and costs are already comparable. Already today comparable to conventional power plants. So we from Proton Motor, we are ready, and yeah, it's on you maybe. In fact, on us. To do the next step for to get this fuel cells into the market and in big amounts, so we will reach this prices and get really below the price of actual power plants, conventional power plants. Yeah, finally, I just can say thank you for your kind attention, and if you have any more questions, you find me at booth E40 or E31 or some of my competent colleagues. Thank you.
Thank you.